So the constant proportionality, our unit rate, what can we do with it? We've been solving with it on this previous practice, but I don't want to have to write the unit in words every single time, so we're going to assign some more variables. Okay. So we're going to say our I can statement, so our goal for these notes, is to be able to write an equation that describes a proportional relationship. So to describe a proportional relationship. So what we've been seeing is if something is proportional, okay, it's going to have that constant change, our constant of proportionality. And so in math, we use equations to kind of abbreviate that or shorten it, so I don't have to write the words every time, but I can say, hey, this variable is going to be my miles, and this variable is going to be the hours. I can find the miles per hour. So let's remind ourselves, our constant of proportionality is just the unit rate from the ratio of y to x. Okay, so K represents our constant of proportionality. I can spell it constant. There we go. And we get it by doing y divided by x. So in our equation, all you do is you take that constant, so where K should go, and you substitute that. So whatever we find our unit rate to be instead of K, I just replace that with the number. So thing Y comes from the unit rate times thing X, which is kind of what we've been doing. We're just putting variables and formalizing the name of it now. Okay? So this first situation says an employee is paid weekly. After working for 9 weeks, they have earned $2,835. Okay? So our constant of proportionality, our unit rate, is y divided by x. And we're going to find how much did they earn per week. So I'm going to take the earnings, the money they got, divide it by the number of weeks they worked for. Okay, and they get $315 per week. So for the equation, what color do I want? This works. Okay. So in this case, I didn't know what y and x were, but if I know that the money per week, that means my money is going to be y and the weeks are going to be x because they're in the same spot in the problem, right? They've lined up. So for my equation, y, the amount of money comes from my constant of proportionality, 315, times x, which is my number of weeks. So all I'm doing is instead of writing out the word weeks, I'm letting a variable represent that thing. Okay? So to interpret a point, points are always labeled x then y. So my x is the number of weeks. Okay, and its value is 1 because it's in the same spot as x. So we're just going to write a short sentence. So after 1 week, then my y is the second number, and that represents the amount of money they've earned. So after 1 week, the employee earns, and then we just take that number from y, 325, and put the label on it that it's dollars. Oh, that should be a 315. My bad. Someday I won't make typos, but today's not that day, y'all. All right, go ahead and change that to a 1. So we're just letting x and y represent something, represent a unit, and it's holding the place of that till we can replace it with something different. All right, so this table shows the relationship between the pounds of coffee beans and the price. Okay, and tables will label x and y. So our unit rate, our constant of proportionality, comes from the price per pound. So we're going to take the price, and we have to choose a point that has both things labeled. So that has an x and a y. So this is the only one that has both. Okay. All right, so we're going to find the price per pound. So I'm going to take the price, 0.88, so 88 cents, divided by the number of pounds of coffee beans, 1/2 or 0.5. Oops. There we go. And it's 1.76. We're talking about price per pound, so it's $1.76 per pound of coffee. And I know that my price is y, and my pounds of coffee beans are x. So my equation is just y equals whatever you found the constant, the unit rate to be. So 176 times x. Okay. So in this case, our y is the price. So the money comes from my unit rate, $1.76, times the pounds of coffee beans. Okay. So to interpret the point 2 and then 3.52, I'll use this color. Okay, coordinate points are always x, comma, y. So 2 represents x, which is the pounds of coffee. 352 is y, which is the price. Okay. So we can just put labels on those. So we're going to say 2 pounds of coffee. We'll say coffee beans. Will cost. Then I take the y value, 3.52. And y represents the price, so I need to add a $sign. So interpreting a point is just writing a really short sentence that gives labels to the values that x and y are representing. All right, so then we can use this equation, we can use that constant of proportionality to fill in the missing values in the table. Okay, so we know that our price comes from our unit rate times the number of pounds. So my price comes from, so to fill in this one, the missing price box comes from my number of pounds times the unit rate. So to get from the top row to the bottom row, we're going to do times 1.76. 0 times anything is 0, which makes sense. If you don't buy anything, it doesn't cost any money. Okay. My price comes from my unit rate times the pounds of coffee. So 1 times 1.76 is going to be $1.76 for 1 pound of coffee, which we already knew from our unit rate. 3.5 pounds of coffee times my cost per pound is going to be $6.16. And make sure you're putting this part and you're seeing why those numbers are appearing, okay? So then what do you suppose I should do to go the opposite way on the table? So far we've gone from the top row to the bottom row, but now I'm going from the bottom row to the top row. What do you suppose I should do? Well, if we're going the opposite direction, then we should do the opposite operation. The opposite of multiplying is dividing. So now I'm going to divide by the unit rate. So 1056 divided by 176 is 6 pounds of coffee beans. So just formalizing with an equation how to use our unit rate. Y comes from our constant of proportionality, the unit rate, times X.